Hello friends, welcome to 5th lecture of function. In this lecture of calculus, function part 5, we will be studying about calculating domain and range of quadratic function and rational function. We know that quadratic function is a polynomial of degree 2. So, consider a function f of x equal to ax square plus bx plus c, where a, b and c belongs to a real number and a should not be equal to 0. Now we will write quadratic function in a new fashion. So in step 1, take a common from the function f of x equal to ax square plus bx plus c, and in step 2 we add b square by 4a square and subtract the same term b square by 4 square from c by a. Now the first 3 term in the step 2 completes to form a perfect square, and the last 2 term in the second step after taking LCM becomes 4ac minus b square by 4a square, which is shown in the step 3. In the last step we can write a within third bracket x plus b by twice a whole square minus d by 4a square, where d equal to b square minus 4ac. Here d is known as discriminant. Now from the last equation we can extract so many information about graph of the quadratic function, and then we can simply calculate range of the function. So let us analyze the domain of the function of the quadratic function. Consider f of x equal to ax square plus bx plus c is the quadratic function where a, b, c belongs to a real number and a not equal to 0. Think function f of x as a sum of 3 functions, f1 of x, f2 of x and f3 of x, where f1 of x equal to ax square, f2 of x equal to bx and f3 of x equal to c multiplied with x to the power 0. Now we have already studied about power function. From our previous lecture we know about power function. We know that the domain of power function, that is x to the power n, is all real number if n is non-negative integer. So now look at the 3 functions, f1 of x, f2 of x and f3 of x. These 3 functions are also a power function. So we can say the domain of f1 of x, f2 of x and f3 of x is all real number. And in our lecture of function part 4 we have studied the combination technique of a function. Now here we can say f of x is the sum of all the 3 functions, f1 of x, f2 of x and f3 of x. So while combining function we have to keep in mind that the domain of the function f is equal to the domain of function f1 intersection domain of function f2 intersection domain of function f3. That means the domain of the function f, which is the quadratic function, is the common domain of function f1, function f2 and function f3. So the domain of the function ax square plus bx plus c is also a real number. Several cases to consider. First, in order to calculate the range of quadratic function, let us draw the graph of the above function f of x equal to a within third bracket x plus b by twice a whole square minus d by 4a square, where d equal to b square minus 4ac. Consider the function f of x equal to ax square, and we choose a greater than 0, and here in our figure we choose a equal to 1. Now if we shift the graph right by minus b by twice a, then new function becomes, as per shifting formula studied in previous lecture, and the new function is f of x equal to a within first bracket x plus b by twice a whole square. Now again if we shift vertically this blue color line by minus d by 4a, then we get our actual quadratic function as shown in the figure. Now case 1, if a greater than 0, which I have already chosen while drawing the graph, and if we choose d less than 0, look at the point minus d by 4a, which is a positive number. Why? Here d less than 0 and a is greater than 0. So the fraction d by 4a will become a negative number, and since there is a minus multiplied by the fraction, so the overall fraction, that is minus d by 4a, will become a positive number. So in the figure 1 you can see the graph is above the x-axis and there is no x value for which the function becomes 0. That is the equation f of x equal to 0 has no real root, and also we can say that the discriminant, that is d, which is b square minus 4ac, is less than 0, gives you an imaginary root. So what is the conclusion here? If we choose a greater than 0 and d less than 0, we can say our function f of x is positive for all values of x. So as we have already talked about the domain of quadratic function, which is always a real number, now we will be going to talk about the range of quadratic function here. So from the graph you can see that what is the range of the quadratic function? Here the minimum value is minus d by 4a and the maximum value of the function is infinity. So we can say the range of the graph is from minus d by 4a to infinity, and it will be a semi-open or semi-closed interval, and the minimum point is x equal to minus b by twice. Now in case 2, for a less than 0 and d less than 0, we choose again the function f of x equal to a x square, but now here a is less than 0. So in the graph you can see the parabola opens downward now. Now shift the parabola by right by minus b by 2 a unit, then we will get the new function f of x equal to a within first bracket we can write x minus again within first bracket minus b by twice a and then whole square equal to a within first bracket x plus b by twice a whole square, and again shifting the parabola down by minus d by 4a unit, we will get the original function. Now here you may be getting little confused because in the previous slide we have seen that the point minus d by 4a which is above the x-axis, but here I have shown you the point minus d by 4a below the x-axis. So why? Because here you can see I have chosen d less than 0 and a also less than 0. So the fraction d by 4a will become a positive number, but here the minus sign is multiplied with the fraction d by 4a. So ultimately minus d by 4a will become a negative number. So here f of x is negative for all values of x if a less than 0 and b less than 0. And what about the range of the function? By looking at the graph, we can easily say that the range of the function is from minus infinity to minus d by 4a. And what is the maximum point, which is x equal to minus d by twice a. Now case 3, here I have chosen a greater than 0 and d equal to 0. So let us see in the graph. So I have again chosen the same function f of x equal to ax square, but now here a is greater than 0. So here the parabola opens in upward direction. Now if we shift the parabola again by minus b by twice a unit in right side, so we will get a new function, that is f of x equal to a within bracket x plus b by twice a whole square minus d by 4a. So now the question is, why I have not shifted this graph vertically upward or vertically downward? Because there is no need of it. Here you can see here d is 0. So the point minus d by 4a becomes 0. So here f of x is positive for all values of x except at vertex where f of x equal to 0. Now what about the range? You can see easily by looking at the graph. The range is from minus d by 4a to infinity, but here the fraction minus d by 4a is 0. So we can say the range is from 0 to infinity, and the minimum point is again x equal to minus b by twice. Now case 4, here a less than 0 and d equal to 0 I have chosen. So the graph of the function f of x will be the almost same as case 3, but since here a is less than 0, our parabola will open in downward direction, and here again d is equal to 0, so our graph will touch the x-axis. That is, here maximum value of the graph is 0 and minimum value of the graph is minus infinity. So the range of the function will be from minus infinity to 0, and here minimum point is x equal to minus b by twice. Now consider again case 5. Here a greater than 0 and d greater than 0. Now let us look at the graph of the function f of x in this case. Consider the same function f of x equal to ax square, and since here a is positive, so our parabola will open in upward direction, and we will be shifting this parabola by minus b by twice a unit in right side, and we will be getting a new function, that is f of x equal to a within first bracket x plus b by twice a whole square. And now since d is greater than 0, we will be shifting this parabola downside by minus d by 4a unit. And here our new function is f of x equal to a within first bracket x plus b by twice a whole square minus d by 4a, which is the original function. Now the question is, why I have shifted this function downside by minus d by 4a. Now look at this point minus d by 4a. Here d is greater than 0 and a is also greater than 0. So the fraction d by 4a is greater than 0, and since it is multiplied by a minus, so the overall fraction minus d by 4a is a negative number. So from the graph we can see our function intersect the x-axis at 2 points, say alpha and beta. So we can say that alpha and beta are the roots of the equation f of x equal to 0, where I have chosen alpha is less than beta. Now for f of x greater than 0, when x belongs to open interval minus infinity to alpha union open interval beta to positive infinity, and f of x less than 0 when x belongs to open interval alpha to beta. So what about the range of the function? The range of the function is from minus d by 4a to positive infinity, and the minimum point is x equal to minus b by twice. Similarly, for case 6, I have chosen a less than 0 and d greater than 0. So here you can see in the graph the point minus d by 4a becomes a positive number. Why? Since d is greater than 0 and a is less than 0, so the fraction d by 4a becomes negative, and since it is multiplied with a negative sign, so ultimately the whole fraction becomes positive. Now, can you say why the graph is open in downward direction? Yes, you are right, because here a is less than 0. So here again you can see the graph touch the x-axis at 2 points, alpha and beta, and from the graph you can easily tell f of x is less than 0 when x belongs open interval minus infinity to alpha union open interval beta to positive infinity, and f of x greater than 0 when x belongs to open interval alpha to beta. Now what about the range of the function? It is from minus infinity to minus t by 4, and the maximum point is x equal to minus dy twice. Now let us talk about how to calculate the range of rational function. Let f of x equal to ax square plus bx plus c and g of x equal to px square plus qx plus r. Here both f of x and g of x are quadratic function, where a, b, c, p, q and r belongs to real number, and a and p should not be equal to 0. And we already know the rational function r of x is a ratio of two polynomials. Here both the polynomials are quadratic function. So r of x equal to f of x by g of x, where x belongs to real. Now how to calculate the range of a rational function? We will choose a variable y that is equal to f of x by g of x equal to ax square plus bx plus c by px square plus qx plus r. Then while cross multiplying the term and arranging the term, we get a minus py within first bracket multiplied by x square plus b minus qy within first bracket multiplied with x plus c minus ry within first bracket equal to 0, as shown in the slide. Since x is real number, so we have to solve the inequality, that is b minus qy whole square minus 4 within first bracket a minus py multiplied with c minus ry, which is also in the first bracket, and the whole inequality should be greater than or equal to 0 to obtain the range of rational function. So how we obtain this inequality? So look at the above equation. Just above the inequality, you can see that the above equation is also a quadratic equation. Since x is real, so in the quadratic equation, if x is real, then we have to solve the discriminant, and the discriminant must be greater than or equal to 0. Here the inequality which I have shown in the slide is nothing but the discriminant of the quadratic equation just above this inequality shown in the slide. Now let us solve some problem related to the range of quadratic equation. Now here the question is, solve the range of the function f of x equal to x square minus x minus 3. So how to solve this? Compare the function given with the standard function f of x equal to ax square plus bx plus c. So here a is equal to 1, b is equal to minus 1 and c is equal to minus 3. Then calculate d, which is b square minus 4ac. So by putting the value of b, a and c, we get the value of d is 13. So again check here that whether a is greater than 0 or less than 0, or d is greater than 0, less than 0 or equal to 0. So by inspection we found that a is greater than 0 because the value of a is 1 here, and d is also greater than 0 because the value of d is 13. Then again we calculate the point minus d by 4a. Remember, the point minus d by 4a always represent either the minimum value of the quadratic function or the maximum value of the quadratic function, depending on the all the cases of quadratic equation which we have studied in our previous slide. So here minus d by 4a equal to minus 13 by 4, that is, it is a negative number. So the range is simply minus 13 by 4a to infinity. Now how to solve the range of function which is rational, that is x square minus x plus 1 by x square plus x plus 1. So as we have studied in our previous slide, we will choose a variable y which is equal to x square minus x plus 1 by x square plus x plus 1 and compare the above equation with y equal to ax square plus bx plus c by px square plus qx plus r. Here a equal to 1, b equal to minus 1, c equal to 1, p equal to 1, q equal to 1 and r equal to 1. Then we will simply write the quadratic equation which is obtained by cross multiplying and arranging the rational function, and we put the value of a, p, b, q, c and r in the quadratic equation, and we obtain 1 minus y within first bracket multiplied with x square plus within first bracket minus 1 minus y multiplied with x plus 1 minus y equal to 0. And we will solve the inequality if x is real, that is b minus qy whole square minus 4 multiplied with a minus py and multiplied with c minus ry greater than or equal to 0. So here the inequality becomes 1 plus y whole square minus 4 multiplied with 1 minus y whole square greater than or equal to 0. And while solving this inequality, we get the value of y which is greater than or equal to 1 by 3 and less than or equal to 3. So the range of the rational function is from 1 by 3 to 3, and which is a closed interval. In the next part of the lecture, we will be talking about trigonometric function and inverse function. So thanks for watching. Please subscribe, stay at home and stay safe.